This is our first of two panelist discussions, one today, one tomorrow. Image analysis has well and truly become an integral part of scientific method involving imaging. I'm sure you all agree that it has moved out of the shadows of it being an optional, nice to have add-on of imaging. The community is growing with more and more formal image analyst positions being advertised and filled, and even dedicated bioimage analysis core facilities being set up. Today's panel will discuss the role of image analysts in institutions. So our panelists today are Stefania Marcotti from the King's College London, Tatiana Voller who is a bioimaging data expert at the Flanders Institute for Biotechnology in Leuven, and Christian Tischer, our speaker just now from the EMBL in Heidelberg. I would like each panelist to say a couple of words how they became to be a bioimage analyst. We all have fairly different routes, or become a bioimage data expert, and what they see as the role of image analysts in institutions, both local to them as well as for the community as a whole. Clearly I've spoken for too long. And once they've done that, just for a couple of minutes each, I would like to open the floor to questions from the audience. And if last year's anything to go by, it should be a lively but friendly discussion. Thank you.
Okay, I guess it's me first. All right, so I like Pete's description earlier today that he became an accidental bioimage analyst. I think that was my path as well. I'm a mechanical engineer by training, and I ended up needing to analyze my own data, and I realized I really enjoyed it, and then things got a bit out of hand. So I joined as a postdoc, mostly experimental group that's very heavily doing imaging, and therefore I became their local go-to person for analysis. And I really enjoyed that part really much. And now I recently joined core facilities part-time to support more users and more projects within King's. I think I will leave the introduction to the rest of the panel before we move on to your second question.
Okay. Okay, so can you hear me, correct? Better? No.
And now? Oh, sorry. So I'm coming from a different angle because I'm a computational chemist by training. So I would say I'm not a microscopist. I have a lot of experience on HPC in general. And so first I was hired as data expert doing some research data management. And then came the question on reproducibility. And then there I switched also a bit to image analysis, of course, on HPC. So it would be.
Hi, I'm a physicist by training. Then I did postdoc and so on, and PhD with microscopy and biology. Yeah, and then I joined the microscopy facility, and then kind of slowly, gradually did more and more image analysis, and then it kind of developed into what you just saw.
I guess it's me again. The question was related to how we see bioimage analysts in institutions. I think it's slowly changing. There's more of us, as this room kind of show. So I think it's becoming a role that's a bit more recognized. If you want fancy images, qualitative is not sufficient anymore. So we need somebody that sits, I guess, in between the experimentalists and the developers, and make sure they can communicate with both. That's how, at least how I see the role. And I think our role in the institutions is really creating and being part of a community that can bring different skill sets together. Not to say that we are expert in everything, but trying to communicate with all the sides. I think it's part of the role for sure.
I fully agree with that. And I would also add to the fact that we also have a role as a trainer to train our user, because we cannot do everything for the user and they should also be able to do a part themselves.
Yeah, so I spoke a lot, but maybe one thing to add. So I was thinking a lot what the title of my talk should be. It could have also been Bioimage Analysis Service. In the end, I decided for Bioimage Informatics Service. And actually one reason maybe is that also maybe Tong's talk in the afternoon, I think where it maybe could go more now is with like combining, for example, all the single cell stuff with imaging data. So maybe it could move a bit closer into like classical bioinformatics and bioimage analysis. Maybe maybe could become a bit closer together in the next couple of years. Let's see.
Maybe just one question before I open the floor to questions. Who in the audience has a role title of image analyst? That's probably more hands than last year, so it is a trend that we're seeing. And yes, I would like to invite you to ask any questions you might have. And I'm dying to throw this thing.
So I guess it's kind of a follow-up to what Christian just said. I mean, first of all, I suppose, are each of you seeing more spatial omics projects coming your way? And this follow-up to that would be, where do you see that going? So do you see us integrating more with classical bioinformatics, or perhaps you have some other thoughts on that?
Not much, and mostly because the users I interact with and the researchers I interact with are not interested yet in the topic. I'm sure that's going to change, but so far, indeed, because we haven't done enough training, I guess, a lot of the problems that I get asked to help with are relatively introductory. How I count my cell, how I segment these blobs, can you track the green signal, and these kind of questions. I'm sure things are going to change. Also, the more we manage to provide training for these tasks to be solved more widely by experimentalists, but maybe more points over there.
I have to say we have a new core facility just for spatial omics because it's developing, and then it's also more between bioinformatics and also AI and this part. So it's coming.
Yeah, so yeah, we also have, it's not really a group, but we have, it's called the Gene Tech Dev team. So there is definitely spatial omics. Then, as I mentioned, I'm kind of co-supervising two people that work for this pharma company. This is only spatial omics, and in terms of and they also actually then match whatever they find in the spatial omics with whatever they find for this similar same sample with single cell sequencing. So that's definitely a thing. And then also in terms of methodology, so we have groups at EMBL like Oliver Stekle and Wolfgang Huber, and I think they publish also papers now about such things, and they are not really bioimage analysts in that sense, right? They're more normal statisticians, let's say. And then I think another, like this spatial statistics, I think is some sort of thing, right? Where they also now the statisticians become interesting in this, and this as definitely methods that we should all use. So I think that's also, I guess there's things happening.
I'm not sure I'll get that far.
On. I don't need to be that loud. So now that we're starting to actually accumulate some bioimage analysis facilities, I've seen some that are included in microscopy facilities, some that are sort of standalone, some that are part of IT, and some that are part of bioinformatics. Which of these is best and why? I want to start a fight.
I think one point in favor of being at least in close contact with the microscopists is that if images are not good enough for analysis, it's a lot easier to talk to the imaging experts and get these communications a bit more streamlined. This said, it looks like a lot of the time IT is somewhat hard to get around. So maybe a closer contact to IT would also be beneficial. What my colleagues think?
I would say it's nice to have the best of both worlds, because I'm in two cores. I'm in the imaging core, but I'm also in the data core. So I get a bit both worlds, and I'm also in close contact with the HPC team, so I can see both worlds and bother both worlds.
And I mean, you have seen my slide in the beginning. I mean, I kind of had to deal with the fact that there are already all these people, but it's also, and they are in fact a mixture, right? And I think it's good like that. So you, and maybe indeed both, maybe there could be some sort of core team of maybe, I don't know, it doesn't have to be too many, 2-3 people that are really the bioimage analysts, but then maybe the group meetings they have every week could include other people from microscopy and so on. So maybe a mix could work.
Hi. Oh, I'll keep it further away. I was wondering if you had any advice for those of us that don't necessarily have bioimaging in our title, but have become sort of the local experts in that. So I get, I've developed these skills over many years, and now I'll routinely get PhD students and other people in the lab come and asking me questions. And I want to say yes to all these people to help them out, but I'm sort of plugging a hole which the core facility doesn't provide necessarily at the moment. So it's how to navigate that situation when all these people are asking me for help. And then I think a lot of time people forgot they've asked me for help in the first place. And then, so it ends up being a lot of my time. And I'd love to help everybody in that situation, but I'm finding struggle to navigate the situation. What's the best thing to do there?
Lobby your institution for a new position.
Yeah, exactly.
Really.
Can you maybe say what your official job is?
Just a postdoc.
And what do you, I don't know.
If that makes you feel better, you're not alone. I'm a postdoc 60% of the time, and just 40% since very recently joined core facility to support more users. So it is changing, but it's not changing fast. And it required, at least in my case, a lot of support from the academics that said, really, we would love this to happen, but it's still a trial. We still need to convince management that this is a role that's needed. And it's great to see that this has been successful in other institutions, like Christian showed, but there's many around here that I know are in this position and take these as examples, but it's not always easy, I would say.
I mean, this is sort of why this whole, do you know CBIAS, the conferences?
No.
No, okay. So actually, maybe, okay, so then all the others might know or not, but like basically, because of people like you, the Kota, Miura, and others founded, like, I don't know, now a couple of years ago, this network of European bioimage analysts, okay, this was an EU-funded thing, cost action it was called, and basically the main point was that exactly there's all these people like you, and they have a kind of, they don't really have a job title. And then I think the word bioimage analyst didn't even exist before. So they actually made it a thing. And now there are job advertisements that have bioimage analyst in the title, which was actually not, as far as I know, non-existent before. So to basically give you the chance to say to your upper management, hey, maybe I'm a bioimage analyst, would you like to hire me at that and give me a staff position or something? And then say, hey, that happens also. And you can now make the case that this is not your, like, that there are actually a lot of job advertisements like that all over the place.
And just to add, the University of Liverpool has just recently this year established a new career pathway for kind of permanent staff that have specific technical skills. It's a research technologist pathway. So do have a look at that as well, and maybe say, it's like, this is a really successful model that has been established. They've had loads of requests from other institutions that also want to adopt it. And that might be a way forward to push for that kind of position, but also a career path to go with that position, which is the next thing you need or you want. Yes, please.
I would love to ask the question where we're heading to. So my take from today, listening to the talks, is we are both simultaneously hiring the bar and lowering as well at the same time. So on the one hand side, we're raising the bar by making or requesting that people deploy containers on HPC centers. Maybe in the future, this needs to be on, I don't know, virtual machines on Kubernetes, or what do I know? But this is escalating in one direction. At the same time, we see that ChatGPT and other resources help doing the coding. So therefore, I wanted to ask you folks where you think we are heading. Will your role be, which will be your role in this changing environment?
I wish I knew. I think the communication point for me is key. These tools that are like ChatGPT are, of course, very useful. I think a lot of us use it daily, but it's always a case how good are you to ask questions to ChatGPT, or do you need to know of things that are behind the scenes? I think the communication role is still key in between the developers that go on at very fast speed with all of the deep learning things, and the experimentalists that go at very fast speed with, for example, microscopy acquisitions. But what's the link between the two? And I still see these as the role of the bioimage analysts going forward. This said, I'm not sure what's going to happen. Maybe you have more insights.
But I will say what I don't know is, because I think in 5-6 years you will have quantum computing available for public, and this will change a lot. I think also for AI, but also for the way you represent your data. And there that's why I cannot say in 5-6 years how it will look like, but I would be curious to test it out. So that would.
Yeah, I mean, I think I have a lower. I think just establishing a sort of culture now where image analysis workflows are reproducible in some sort of decent way would be my aim for the next couple of years, because I don't think we are there, right? I mean, like clicking in the GUI is definitely not super reproducible. So I think anything that changes the culture a bit towards something that can be rerun and is then also published in a way that can be rerun would be my short-term aim. And then let's take it from there once we achieve that, I would say.
Can I have a follow-up one on this?
Yeah, we've got plenty of time.
Because I'm not sure that the culture change would need to be there with the analysts, because it's also on the developers folks side. I mean, the fact that we have so fast circles of new releases and everything, I mean, that literally is hell-bent to break all dependencies all the time. So that again points more towards raising the bar with more stringent and more nested deployments of, like you said, having a container and then on an HPC and whatever further. So I would paraphrase your answer more like you're seeing more of this stuff in the future then.
Yeah, maybe in the near future. I mean, if you have a better suggestion, I'm happy, right? I mean, I'm just.
No, I don't have a better suggestion. I
Okay.
just see what's happening there, and I think there's no way that I think a culture change is happening that we have slower release cycles of software, or everyone is stopping right now and saying like, "This is good." You know, I'm not so.
I think it doesn't. I think as long as there's some version of the thing somewhere, then it doesn't have to be a slow release cycle, right?
But yeah, sorry, just a quick remark. But if what would be also helpful, because you mentioned easy build, which is very nice because you can have it on different cluster. It would help a lot if most of the open source software for image analysis would be available as an easy build. We have been kicking a bit our local HPC to do so, but there are still many that are still missing.
Yeah, I think actually in the Netherlands, I mean, our IT guy is always telling us there's something like Easy Build, but better. And I don't know the name, but that's what he thinks maybe is the future, but I forgot the name of it.
I also wanted to say, like, container and easy to use doesn't have to be mutually exclusive. There's really easy ways now to put GUIs inside containers. And so we can make stuff that, as long as someone can download the Docker Desktop program on their computer, we can run something, the exact same container, in an HPC or in a GUI. And the user doesn't have to understand what a container is. They just have to hit play.
I actually just want to make a shout out for CellProfiler, also answering your question, because they are really good at providing old versions of CellProfiler on their website. It is amazing. So I think they are really doing a very good job. I think it's not so easy for Fiji to get the version from 2 years ago, but CellProfiler, if you have an old pipeline, I think CellProfiler is really thumbs up.
Dave, I think there's a question from the
Yeah,
virtual audience.
few questions online, a couple of long ones. I'll try and summarize, somewhat relevant to this discussion. So traditionally, life scientists don't really have much in the way of computational skills. No offense to anyone in the room. Do you sense that that's something that's shifting? Do you encounter more people with, scripting experience, coding experience? And something of a follow-up question to that then, do you find that the people without computational skills are more difficult to support?
I mean, ChatGPT indeed should help there. I'm actually not a Python programmer, for example. I mean, I can write code, but then I don't write Python code. I just add ChatGPT, but I at least can then read it. But I guess that should help people a bit to write code. And I forgot the second part of the question, but maybe you can.
But I can see you have like things like the biomodel zoo, and inside you have the zero cost for deep learning notebooks, where you have one version where you can just click and just enter and you don't see the code. And you have the other one where you can modify the code. But I think with training, it can also help. And if you have those kind of reproducible notebook, then it should facilitate the use, increase the programming skills a bit.
And I think I can add that there's been more people trained in coding. Some courses, even in biology, now provide at least one course in coding that I think might have raised the bar in this perspective. But also I don't necessarily see, like, supporting a person that has training skills or not, I don't necessarily see a difference. It's also down to how good we are at explaining what the algorithm we are trying to design is doing, and how good the software we are using is, like, compared to, I never can pronounce that word correctly. Put things in compartment. I'm sure there's a verb, but it's too long for me to pronounce.
And actually for us, like in terms of providing a service, I'm actually totally fine with this wide range of people, right? I mean, at least they have to be able to copy and paste one line of text and somewhere else and press enter. But I think so far everybody managed. So I don't agree that people cannot use a terminal. I have never seen a life scientist that cannot use a terminal. So I disagree with this. But then there can be all kind of ranges. I think some people then really start writing own code, and others, I think it's okay if there's a broad range. It's actually fun for us to compete.
Yeah, thanks. Just for the people who haven't been here before, what would you guys say is the unique skills and knowledge domain of a bioimage analyst that is not covered by microscopist or bioinformatician?
I would say knowing enough, a little bit of both. So being able to understand the biological question, so at least have an idea on what's the problem, what's the question being asked, and also a little bit understanding what the different tools available can do. There seem to be a lot of tools out there. A lot of them can solve the same problem. So choosing the right one for the job, or one that will perform well, I would probably say is a skill to have.
I would say it's difficult to define, because one thing that strikes me in this community is you have people coming from very, very different fields. And I think that's one of the strengths of this community, that you have people that come from the bioinformatics, from the physics, the mechanics, chemistry, quite a lot. We are invading, I would say, even computer vision. So that's what is nice. And I think that makes us complementary.
Yeah. So complementary and also very different. I think I have, for example, for me, I usually have the hurdle, if the people can explain me what they want to measure, I'm sort of, then that's my entry point. I'm happy, but I have also like quota to mention. I think if he would, after 2 hours, not be convinced that this is a biologically interesting question, he would just not be, you know, I mean, you can have your bar of like where you say I help or how you help, you can put different focus also, I guess. So it's pretty, but I think it's to do this job perfect, you have to be so good at so many things at the same time. It's really hard. So you have to probably be, some people are better at certain aspects of it, I would say.
Just to add one comment is you're a bit of an interpreter between two different languages as well, kind of the programming languages, but also the biology, whereas people can speak about the same things, but they use completely different terms. And then you might have to just say, it's like, you are actually talking about the same thing. You're just using different terms. So there's a level of being an interpreter between the two different camps as well.
So as Zork? Okay, so as someone from one of those mentioned new centers doing image analysis at the Biovision Center in Zurich, I wonder if you could help me with a question I'm having, which is, the time for all of us is limited to do all the things we'd want to do. How would you balance the following three aspects of our work? One, teaching or training people. Two, doing analysis as a service and just directly solving the problem for someone. And three, building software or maintaining software that people need, or setting up infrastructure as you described, Tishy. How do you balance those three now, and how do you see this balance shifting?
Well, I would say first we need more people, basically. Because for the moment I'm more in infrastructure and helping a bit on training, and I guess I will help on analysis. So yes, I will discuss it today with Sebastian, who is in the back. We need more people.
Yeah, definitely more people, more money if possible. But one note I think it's worth making is the community is strong. So I think more community effort sometimes could be beneficial. We all do training, I think, and it'd be nice, at least if locally we could kind of join forces and could help each other out, so that it's not the same person having to do local training for their own institution when we end up teaching roughly the same things over and over again. So yeah, more people, but also maybe more sharing.
Yeah, so for the training, I mean, one motivation also to make this website that I showed was to actually enable everyone to teach stuff without having to come up with their own teaching material. So I kind of I was hoping that might scale a little bit better, right? But for the other stuff, it's a really good question. I don't know. I mean, they definitely need everything, but I don't know, it depends. Some people also say, hey, I only do training and I do nothing for the people. Yeah, I heard also from prominent people of our community, that's what they think that one should do. So I don't know. It's
monitoring demand and changing your job description, if you can, within your institution, as to, obviously not every week, but in the grand scheme of things. Yeah, there's a question back there.
Yes, hi. My question is more on the interpretability and explicability in AI, as in, it's been great meeting so many biologists today, and there's this interesting thing of people later in their career in biology today who use AI, it's more in terms of input and output, where there's less of a question of what does it do, but the black box is definitely there. And so I see today, for example, more in medical image analysis, that we're going to have to explain what's happening, what the model is doing, especially in classification and regression, whereas we've seen lots of segmentation today, so there's less of that. But in terms then of bioimage analysis specifically, should we try and push computational people to have interpretable models rather than big black box models?
So I think we are only using AI for segmentation, and I think there, even before AI, I think the ground truth was always some human looking at whatever you get, if it was an Otsu threshold or AI. So I think in the domain of segmentation, I don't think so much changed. And I think for other applications, I don't really use it. So I can't, and I'm also not an AI expert, but yeah, so I don't really have that problem, I think, at the moment.
I think it's needed to make it more reproducible. I think this year there was a checklist for AI and machine learning workflow. And I think they put a sort of what you should do when you publish a workflow using AI. And then you should put training, test dataset validation, and in the best case, even the container and all the specification of your file. But of your program, but I agree it's difficult, but it is needed, because if you cannot reproduce it, but also what you can do is if you use like some notebook from the Zero Cost for Deep Learning model, then you have things that are also more standardized and so should be more reproducible.
Yeah, I don't have much to add, mostly because there's been a lot of work going on about explainable AI, and people are working very hard to find something in that sense, but it's a hard problem. We don't fully understand, especially the deeper the models get, how it works. So there is work being done, but it's definitely more on the developer side than the analyst side, I would say, but they're definitely working on it. So I guess these things will change fast on these as well.
Thank you very much.
I just very quickly wanted to comment on the previous question, because there was the guy from Zurich that wanted to know how to balance the three things. I think from a personal point of view, there's obviously no right or wrong answer, but I think from a more abstract view of running a infrastructure or running a kind of facility as such, there is some answers that can be given here. And I think without doing any kind of innovation at all, you will be running at risk of just doing and repeating known stuff, and people will in a long-term future not seeing the big advantage of you providing service. So you could argue the range of, I don't know, 20% of doing innovative stuff, building new tools will likely be more or less reasonably good. You need to maintain the majority of your user base. So doing analysis for a large part likely is also good. Training helps you to facilitate and multiply your service through other people. So I guess you would likely do 60% of analysis and the rest in terms of training. I think as a rule of thumb is at least some starting point. Any kind of literature that points to budgeting or doing this in any other kind of facility area would likely be a way to start digging in what the current way is. It also reflects a bit on what the institution is actually giving you as a mandate, because some find often, doing innovation is not so good, but for you personally, I think it's important that you keep track and stay on top of things. So I guess this 20% of innovation is likely the acceptable. It's just a quick comment, sorry for jumping in, but I felt that guy maybe wanted that as a more generic, not only analysis related answer.
Hi, everyone. I have a question. I actually wanted to ask the panelists for some help because I am interested in what sort of strategies do you have to maybe help scientists to promote the tools that they are developing. And I'm saying promote and not publish on purpose, because sometimes it feels like publishing software tools and tools for bioimage analysis are very difficult. You can get into the rat race of trying to benchmark the performance on multitude of data sets, and it might not actually, your tool might not actually score the best in terms of the performance and in terms of the metrics that you're using, but it actually could be super helpful when you're trying to analyze a very particular problem, or when you're trying to develop a tool that perhaps uses a different strategy to everything else that has been developed in the field. So I was just wondering if you could share your views on how to promote the tools that scientists are developing. Do you perhaps recommend to publish preprints on bioRxiv, or do you actually encourage people to go through the peer review process, or is tutorial enough?
I would say, but this very general, the more people use your tool, the more advertisement you get out of it. And this relates to having something that's well documented and open as much as possible. And paper associated to it, bioRxiv, at this stage, not necessarily, doesn't necessarily matter, but the more explanation you can give, the more people will be on board. And first of all, for you, as a developer, you probably get more feedback that's useful, especially if they end up using it in something that's not strictly what you thought it for. And also, I guess, people talking about it will end up being the promotion you need to make it more widely used.
Yeah, and then I think getting courses, like if there's courses happening, and so you developed this tracking tool, right? Yeah, okay. Like if like, I don't know, if somebody invites you to be part of a course and you teach people how to use your tracking tool, that helps. But I think also what Bev, like this I2K, maybe, I don't know, have you given a tutorial there or? No, so there was this like online.
Now I have to.
Yeah. I mean, that thing's a good maybe. So there was this 1 week where people actually, that would have been exactly good, I think, like that have tools just can give a 1 hour workshop online, and then this is even recorded so people can watch it later. So I think stuff like that's probably good.
Be present on the forum if people have questions about your tool.
And if you want to develop it further, what you can also do is a hackathon. And then you have even more people working on your project and disseminating it.
That's some great insights. Thank you very much.
I also wanted to catch up on the question from before. I think it was a very good question that many of us ask ourselves, right? How do you balance all these things? And I think one thing I learned is it's good to discuss with the institution what the goals are that your reviews are going to be about, right? Like what they're going to judge you by in 2 or 5 or how many years ever you're going to get your renewal, or just decide how many funds you have. And one question that I have is is there a set of goals that actually works well for such an image analysis platform, however you want to call it, right? Because I think it might vary a lot from institution to institution what people have set as the goals for this platform. I was wondering if there's maybe some advantage in us getting together and thinking about if there's a set of goals that actually works well, that balances teaching and innovation and service in the right way. It's of course always different for each institution a bit, but I think it's a complicated problem.
I think it's a cool idea. I think there's now enough people that kind of do that sort of stuff for a while, like, I don't know, Anna Clem, Jean-Yves, maybe, I don't know. So that actually, yeah, so maybe then getting together and sort of maybe just writing down, hey, that's what we think would make sense, and maybe then our institutions would just happily accept it if they're lucky. But I think it's a good idea to gather some people and maybe write down something.
It might also help people that start new facilities or new services, right? To have some kind of idea, because if you always think this through from the beginning, you're always going to make mistakes the first time, right? That you're going to think we all have learned a lot of from our mistakes that we've done, or also the things that worked.
maybe in that context, I think we are trying now to found this society of global bioimage analysts, and I think one deliverable that we have is every year some workshop, and I think we wanted to make this some also exchange of experience workshops, and maybe actually discuss stuff like that. So Beth is nodding, that's good. So and that would be a good forum maybe. So we would already have the forum, and already actually we need to make this workshop because we got it funded. So then yeah, good point.
There's also a recent publication in the Journal of Microscopy from Robert Hasse regarding just this, so how to start a facility and what are his thoughts about it. Of course, is the view of one person, and something more wide could be beneficial, but that's definitely a good starting point to bring to the different institution to say, this has worked for them, can we do something similar? So that's definitely one thing to look at.
Thanks.
So we've recently started set up our own image analysis unit at our institution, and I was just wondering how you all approach not only letting users know what the benefits and necessities are of image analysis, but also trying to encourage users to actually come to you to not only to kind of justify your existence as part of it, but also to improve their workflow.
I think there's a little bit of a shift that has to happen. A few academics are already on board, and they will lead by example by showing how much more you can get out of the data by doing quantitative analysis instead of just looking at pretty pictures and pretty images. But a lot of it is going to knock on doors and talk to people and show what can be done. We are trying to set up some sort of like informal chats where people can just come with some data and discuss what could be done. But it's a lot of, talking to people and training, of course, will help. I'm not sure if there's further insights.
Give a talk at your institute is probably good.
Yeah, training. And I think you can also refer to training, like one training that was very nice at school was from Neobias, the defragmentation school, that you can also say, look what they can do there.
Thank you.
Okay, one last question from the online community, and then I think we'll have to wrap it up.
I think this is a good one to wrap up with. So I'll try and summarize. So do you think, I mean, data sets, as we all know, are getting more and more complex and getting bigger and bigger. So the computational resources required to analyze them are getting more and more vast. Do you think this is presenting a significant barrier to perhaps less well-funded groups? And if so, what do we do about it?
Better infrastructure?
Acquire less data? I mean, seriously, I think often people just, I am really fighting. People come always to me with these confocal microscopy images where they just press the optimum button and it's completely ridiculous, but it's really hard to convince. I think Jean, Kali, is she here? I think it's her vision now to tell people that you can acquire data with less resolution and it's still good, right? Yes, okay. So I think that's maybe another idea.
Sorry.
But what you can do, but it takes some time. You can also, because you have local HPC nationally, but usually the caveat is that you have to do a grant application. You have also this at European level, but there is nothing as a free lunch. So if you get free computational time, you have to do an application. And there typically you have benchmark. And so there you would need someone with HPC experience or help from the people that you can do this application.
I think one last note is to remind everybody that's good to start preliminary analysis very early on when the data is small to see what can be achieved before things blow up and become exponentially harder, both to store, to move, and to analyze. So talk to your analysts early on so that first of all, we can adjust course in case better or different imaging is needed, but also so that we can figure out from the beginning what can be done with those data sets before they become too big.
That you don't have to rename all of your files after you've recorded them.
Not if you use Christian New.
Exactly. Right. I would like to thank you all very much for your lively participation. I didn't have to fall back on my pre-prepared questions. And I would also like to thank our panelists for the discussion.